That seems way too clean, too stable, too perfect, and something felt off. You were probably right. Today I am breaking down cell constant. What k equal to zero point 0.1, k equal to 1.0, and k equal to 10 actually mean, and why picking the wrong one is the most common reason conductivity meters give you confidently wrong numbers. I have seen this trip up Pharma QC labs and ETP engineers alike. So let's fix it. Here's the thing nobody tells you about conductivity meters. A wrong cell constant doesn't throw an error. It doesn't flash a warning. It just gives you a stable, repeatable, completely wrong reading. And that's actually worse than an erratic one, because nobody questions a number that looks clean. I have walked into labs where the meter was fine, the electrode was fine, the calibration looked textbook, and the cell constant was set wrong for the sample. That's the reading that fails an audit. So, what is cell constant? In simple terms, K is a fixed geometric value measured in inverse centimeters that describes the spacing and surface area of the two electrodes in conductivity probe. Here, the part that matters. Your meter doesn't measure conductivity directly. It measures conductance, the raw electrical signal, and then multiples that by K to give you true conductivity in microsiemens or millisiemens per centimeter. Think of it like a camera lens. The sensor doesn't change, but the lens will determine what range you can actually bring into focus. Wrong lens for the scene, and you get a sharp, confident, and completely unusable photo. So the process is electrodes measures conductance, thus get multiplied by your cell constant, and the result is what shows up on your display and what goes into your audit trail. If K is wrong at step 2, everything downstream is wrong too. No matter how good your electrode or your calibration technique is. Let's go through the three common values, starting with K equal to zero point 0.1. This is built for ultra pure, low conductivity water. Think WFI, USP, or IP purified water, RO permit. Typical range is zero point 0.5 to 200 microsiemens per centimeter. If you are a Pharma QC analyst running stage 1 compliance testing on purified water, this is very likely the probe you should be reaching for, not the one that shipped in the box by default. Next is K equal to 1.0, the general purpose workhorse, and almost always the factory default on benchtop and portable meters. It covers roughly 10 microsiemens up to 20 millisiemens per centimeter. Drinking water, cooling tower, markup water, general purpose water. If you only want one probe, this is probably it. But default doesn't mean correct for everything. That's the mistake I see most often. And K equal to 10 is the high end brine boiler blowdown ETP discharge with high dissolved solids, concentrated cleaning solutions. Anything above roughly 20 Siemens per centimeter, the electrode spacing is narrower here, built specifically to handle a strong signal without saturating it. Let's put all three side by side. K equal to zero point 0.1 for Pharma QC, ultra pure water, K equal to 1 for general industrial and process water, K equal to 10 for high conductivity industrial and ETP samples. If you remember nothing else from this video, remember this table. Screenshot it if you need it too. So, how do you actually choose? 5 steps. 1. Estimate your sample's expected conductivity range from your SOP or previous batch records before you even pick a probe. 2. Match that range to k equal to 0.1, 1.0 or 10 using the table we just covered. 3. Verify with a certified standard solution close to your expected range, not a generic mid-range standard sitting on the shelf. 4. If your lab tests both ultra-pure water and high conductivity effluent, don't try to make one probe do both jobs. Keep dedicated probes. And 5. Re-verify your cell constant annually because electrode wear and fouling can shift it slowly over time without you noticing. A few mistakes I see constantly using the factory default A equal to 1 probe for WFI testing. The resolution at that low end just isn't good enough to catch real excursions. Calibrating with a standard solution nowhere near your actual sample range, a 1413 microsiemens standard tells you nothing useful about a 5 microsiemens sample. Assuming cell constant never changes, it does gradually as the electrode surface wears, and sharing one probe across totally different conductivity range, which just compounds all the above. So here's the takeaway. Match your cell constant to your actual sample, verify it against a certified standard, and don't assume the factory default is right just because it's what came in the box. Cell constant is a spec you set once and forgot. It's the one factor that decides whether your conductivity readings are actually trustworthy. If you are setting up or replacing the conductivity meter, we carry EU Tech and now and aquasol probes covering k equal to 0.1 through k equal to 10 at scispectrum.in. Link and number are on screen. Subscribe for the rest of this conductivity meter series. Thank you.